it appears there is a potential National Electrical Code violation regarding the depth of buried electrical wiring for the lamppost. The National Electrical Code mandates specific burial depths for electrical conductors to ensure safety and prevent damage. According to the information, the wire is buried less than 6 inches deep within 2 feet of the house. The National Electrical Code specifies that wiring within 2 feet of a structure, such as a house, must be buried at a minimum depth of 6 inches. This shallow burial depth poses several risks. Firstly, there is an increased risk of physical damage to the wiring. Lawn equipment, such as mowers and edgers, can easily strike the cable, leading to cuts or breaks in the insulation. This damage can expose the conductors, creating a potential electrical shock hazard and causing the lamppost to malfunction. Secondly, there is a potential electrical shock hazard to anyone digging in the area. If someone is digging in the vicinity of the shallow buried wire, they could accidentally come into contact with the energized conductors, resulting in a severe or even fatal electrical shock. Thirdly, water damage to the wiring could occur. Shallow buried wires are more susceptible to moisture penetration, especially if the insulation is compromised. Water can cause corrosion of the conductors, leading to electrical failures and potentially creating a ground fault, which could energize surrounding objects. To rectify this National Electrical Code violation, several steps can be taken. 1. Contact the original installer of the lamppost. Explain the situation and provide them with evidence of the shallow burial depth and any damage to the wiring. Request that they correct the installation to comply with the National Electrical Code requirements. 2. Verify code compliance. When the installer addresses the issue, ensure that they adhere to the following National Electrical Code requirements. The wire must be buried at least 6 inches deep within 2 feet of the house. The wire must be protected from physical damage by being installed in a conduit or be a direct burial cable rated for underground use. Any splices or connections must be made in an accessible junction box rated for the environment. 3. Seek professional help. If the original installer is unresponsive or unwilling to correct the issue, consider hiring a licensed electrician. A qualified electrician can assess the situation, verify code compliance, and make the necessary repairs to ensure the safety and proper functioning of the lamppost. 4. Document the repairs. Keep detailed records of all communications with the installer and any electricians involved. Take before and after photos of the wiring installation as evidence of the repairs. This documentation can be valuable if any issues arise in the future. Remember that the minimum depth for buried electrical wiring can vary depending on the specific location and soil conditions. However, in this case, since the wiring is within 2 feet of the house, the National Electrical Code mandates a minimum burial depth of 6 inches. Addressing this National Electrical Code violation is crucial for ensuring the safety of people and property. By following the recommended steps, it is possible to correct the issue and prevent potential electrical hazards. Electrical codes are in place for safety reasons. It is important to adhere to them. In addition, more information, such as the wire gauge and breaker size, would be required to assess this situation further. The National Electrical Code dictates allowable ampacities for different size conductors. Also, the circuit breaker must be appropriately sized to protect the wiring from overcurrent. For example, according to National Electrical Code Table 310.15b16, a number 14 American wire gauge copper conductor with type THHN insulation, rated for 90 degrees Celsius, has an allowable ampacity of 20 amps. Therefore, this conductor would need to be protected by a 20 amp circuit breaker or fuse. If the conductor was aluminum with type THHN insulation, rated for 90 degrees Celsius, the allowable ampacity is 15 amps, so it should be protected by a 15 amp breaker. Number 12 copper wire has an allowable ampacity of 30 amps and should be protected by a 20 amp breaker, as per National Electrical Code section 240.4d. Number 10 copper wire has an allowable ampacity of 40 amps and can be protected by a 30 amp breaker. If the wire is direct burial rated, it will be marked as such. Direct burial cables are designed to withstand physical damage and moisture. Using the incorrect type of cable can lead to premature failure. When making any connections, use connectors that are rated for the specific application. These connectors will be marked as suitable for direct burial. Do not leave any exposed metal. This can cause corrosion over time. When burying the cable, avoid sharp rocks or debris that could damage the insulation. It is a good idea to put a layer of sand beneath and above the cable to provide a buffer. Backfilling with the soil that was originally removed is preferable to using filled dirt. If filled dirt must be used, make sure it does not contain any large rocks or debris. Compacting the soil after backfilling will help to prevent settling. However, be careful not to damage the cable. If multiple cables are being buried in the same trench, maintain adequate spacing between them to prevent overheating. The National Electrical Code provides guidance on the required spacing. It is also a good idea to install a warning ribbon above the cable. This ribbon will be a visual indicator to anyone digging in the area that there is an underground cable present. The ribbon should be buried approximately 12 inches above the cable. If the lamp post is located in an area that is subject to vehicular traffic, the wiring must be installed in a rigid metal conduit or intermediate metal conduit. This will provide additional protection from physical damage. When running conduit underground, make sure to seal the ends to prevent water from entering. Water can cause corrosion and damage to the wiring. If the lamp post is located near a swimming pool or other body of water, there are additional grounding requirements that must be met. Consult the National Electrical Code for specific requirements. If the lamp post is controlled by a timer or photocell, make sure that the device is rated for outdoor use. These devices are designed to withstand the elements and will last longer than indoor rated devices. When installing the lamp post, make sure that it is properly grounded. This will help to prevent electrical shock hazards. The grounding electrode conductor should be connected to a ground rod or other approved grounding electrode. If the lamp post is located in an area that is subject to lightning strikes, consider installing a lightning protection system. This system will help to protect the lamp post and other nearby structures from damage. A lightning protection system typically consists of air terminals, conductors, and grounding electrodes. The air terminals are installed on the highest points of the structure and are designed to intercept lightning strikes. The conductors are used to carry the lightning current to the grounding electrodes. The grounding electrodes are used to dissipate the lightning current into the earth. When installing a lightning protection system, it is important to follow the manufacturer's instructions and all applicable codes. The system should be inspected regularly to ensure that it is in good working order. If the lamp post is powered by a low voltage system, such as 12 volts, the wiring requirements are different. Low voltage systems are generally safer than high voltage systems, but they still need to be installed properly. The National Electrical Code provides guidance on the installation of low voltage systems. When installing a low voltage system, make sure to use the correct type of wire and connectors. The wire should be rated for the voltage and current of the system. The connectors should be designed for use with low voltage systems. If the lamp post is powered by a solar panel, there are additional requirements that must be met. Solar panels generate direct current, which must be converted to alternating current before it can be used to power the lamp post. This conversion is done by an inverter. The National Electrical Code provides guidance on the installation of solar panels and inverters. When installing a solar panel system, make sure to use the correct type of wire and connectors. The wire should be rated for the voltage and current of the system. The connectors should be designed for use with solar panel systems. It is also important to properly ground the solar panel system. This will help to prevent electrical shock hazards. If the lamp post is located in an area that is subject to extreme weather conditions, such as high winds or heavy snow, there are additional considerations that must be taken into account. The lamp post should be designed to withstand these conditions. The wiring should be protected from damage. The National Electrical Code provides guidance on the installation of electrical equipment in extreme weather conditions. When installing a lamp post in an area that is subject to extreme weather conditions, make sure to use the correct type of materials. The material should be resistant to corrosion and damage from the elements. It is also important to properly secure the lamppost to prevent it from being blown over or damaged by snow. If the lamppost is located in a commercial or industrial setting, there may be additional requirements that must be met. The National Electrical Code provides guidance on the installation of electrical equipment in commercial and industrial settings. When installing a lamppost in a commercial or industrial setting, make sure to comply with all applicable codes and regulations. It is also important to have the installation inspected by a qualified electrical inspector. If you are not comfortable performing the electrical work yourself, it is best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to install the lamppost safely and correctly. They will also be familiar with all applicable codes and regulations. When hiring an electrician, be sure to check their credentials and references. You should also ask for a written estimate before the work begins. When the electrical work is complete, be sure to have it inspected by a qualified electrical inspector. This will ensure that the work was done properly and that it meets all applicable codes and regulations. By following these tips, it is possible to install a lamppost safely and correctly. The lamppost will provide years of reliable service. The National Electrical Code is updated every 3 years, so it is important to stay up to date on the latest requirements. The National Fire Protection Association publishes the National Electrical Code. The National Fire Protection Association website has information about the National Electrical Code and other fire safety topics. Many local libraries also have copies of the National Electrical Code available for reference. It's important to consult the most recent edition of the National Electrical Code for the most up-to-date information. Changes and revisions are made regularly to address new technologies and safety concerns. If you're unsure about any aspect of electrical installation or repair, it's always best to consult with a licensed electrician. They have the expertise to ensure the work is done safely and in compliance with all applicable codes. Doing so can prevent potential hazards and ensure the long-term reliability of the electrical system.